Okay, so what I wanted to do is give you guys kind of an overview of this eventer that I put together for you that hopefully you can modify to use for your project. I think once you start designing the state machine and trying to get it to work, you'll figure out whether this was the right approach to solving your project's problem or not. It's not necessarily a given that a state machine design is the best thing for every project. In fact, I know it's not the best design for every project, but I think you'll find out when playing with it whether you are making the right choice by starting to go with the state machine design. So just like the demo code I've given you already, there's two basic pieces along with a slightly modified version of the event that I've already published. There's an eventoid that fuses together data from two sensors. And there's a demo program that drives the eventoid just to demonstrate that the eventoid actually does what it claims to do. There's two general approaches. Like I said before, I don't want to do your project for you. So I had two choices. And the two choices are, so the premise is that for me to know that what you want to do is doable, I basically have to do it myself. And then I'm left with two choices. I either do exactly what it is that you're going to do and then rip all the guts out and let you refinish it yourselves, or I kind of solve a problem similar to the one you want to solve, but I kind of do a perpendicular version of it, not exactly what you want, but kind of, but not really. And I've actually chosen the second solution. I'm going to recap what I think you guys are trying to do. I think the idea was that you had some sort of vehicle, like a bike or something, and you wanted to be able to do some sort of warning or correction system based on the current speed which you were measuring from a hall sensor on a wheel spoke, plus an accelerometer that's mounted somewhere on the bike, I guess to measure tilt. So both of those devices are perfectly reasonable choices for what you're trying to do with three magnets on the bicycle wheel. Hopefully that'll give you good enough resolution for speed that you'll be happy with that set of choices for your sensor. I think they'll do fine. We all have the same accelerometer, so that was kind of nice. And what I've chosen to solve is done something it sounds very similar, but it isn't exactly the same. So I took the idea of tilt and the idea of speed, and I made a hybrid eventoid for you guys. Now, the key point is that the structure of this eventoid is probably exactly what you want, but the guts are different. So instead of using tilt the way you might want to do it, you might be doing tilt in like two axes instead of maybe just one. I'm using one axis, and I happen to be using the y-axis of the accelerometer, and I'll show you in a demo later how I orient the accelerometer to kind of fake like it's mounted onto the bicycle. And instead of measuring speed with a Hall sensor, I'm just hooking up a button to a GPIO that rather than emitting pulses, I just press the button and it reports fake speed changes of up and down of like 10 miles per hour. So as you press the button, the interrupts come in on the GPIO. Well, it's set up to use interrupts, but the signal comes in and every transition of the button, I'm pretending like that's a speed change of plus or minus 10. So I'm actually generating a triangle wave of speed. So you start off at 0 miles per hour. Every time you press the button, it goes up 10 miles per hour, and then it tops out at a maximum of like 90 or 100 miles per hour. Okay, so it's a motorcycle, not a bicycle. And then you keep on pressing the same button, and then it decreases down. So if you were to just stomp on the button, you'd generate a jaggy triangle wave up and down. So that's my proxy, my simulation for how speed is entering the system. For tilt, I'm doing something vaguely similar to what you're doing, except I'm not using real trig. I basically decided that I was going to map the 9.8 meters per second acceleration from perfectly vertical to 0 at horizontal. I map that linearly instead of from 90 degrees to 0 degrees, and 9.8 meters per second squared to 0 meters per second squared. I just do a linear interpolation or a linear mapping from one of those ranges to the other. So I don't do any trig. You're gonna have to figure out how to do that yourself using however many axes you want. But point being, the math is fake, but I do have a notion of tilt. Now, I don't know what reference frame you're using. My idea of tilt isn't tilt from the vertical down. So whereas like this would be 0 tilt and this would be 90 degrees tilt, just to make the math and the demonstration easy, my 0 is the Cartesian, uh, 0 vector, 0, 0 vector, xy. Now, I guess that would be x is 1 and y is 0, but around the unit circle. So my 0 is this way, and my 90 is this way. And the reason why I chose 90 miles per hour as the max and 90 degrees vertical this way is my goodness, my safety um, rules are going to be as long as your speed doesn't exceed the degree angle of the tilt of the accelerometer, you're operating in a safe region. So the idea is that if your tilt is 90, you can go up to 90 miles per hour. If your tilt is any less than 90, that's a danger condition because your speed is exceeding your angle. Like I said, where your angle is going from 0 this way to 90 this way. So it made my goodness function, my safety function very easy. It's just basically a comparison between the speed and the angle. And if the speed is greater than the angle, then I call that a bad operating condition. And anything else on the other side of the range is a good operating condition. So um, my understanding of what you guys wanted as far as generating events is that you could get an event when you went from safe operating to dangerous operating and back again, because you were going to do something like manage the speed. I think through trying to use braking to slow the thing down, to slow the bicycle down. So all this model basically kind of works. It's not exactly what you wanted to do, but I think it's a good fake of what it is that you want to do. So this whole thing actually works. So what I've also done, in addition to the making some hacks to the eventoid and some hacks to the demo, is while you're tuning this, and I think this is going to be a big part of your project, is tuning it to get it to behave, with the values you want and figuring out how your tilt and speed relate to each other. I think um, you're going to need some of this kind of diagnostic stuff that I built in. So part of what I have down here in this window is, you probably can't see it here right now, but as I demo it later, I'll pull the camera off and point it right at the screen. The problem is it's hard to do the demo and hold the camera with two hands. So right now the camera's stuck on the tripod. So the point being is that I'm plotting out every tenth of a second. I have a timer that goes off and it gets the current angle and the current speed. And the third data that it plots out is a low value when the last state was event safe. And the other value, the other level is when the last event was an error or out of operation, unsafe operating condition event. So as I demo this, you'll see kind of how all three of these things play together. And because to do plotting, you have to print out a bunch of data in the console window. In addition to the normal event messages that you would see, you also will be seeing the data stream. So I'll probably stop it at one point and page back and show you what the event messages look like. But the event messages are very similar to the ones you've always seen when you've been doing state machine programs in the past. It's just that all this noisy data gets in the way because that's how you have to print out this stuff to get it to plot. So you'll need to put the eventoid, of course, out onto your Pico, and I'm going to give you in the zip file, I'm going to give you another version of the eventer. It may or may not be changed from the one I gave you yesterday, but go ahead and use the one I'm giving you anyways. All three of these files have timestamps in the last modified that are all today, so if you have an old one, you'll be able to tell that they're one or more of them are out of date, and you'll know which version you have. So let me go ahead and start this running. focus on the demo, hit run. So it's actually plotting live. Now let me get out the board. So I am using the accelerometer. I'm holding it. Hope you can see, like, so you see this in the light. The connector is down and the accelerometer chip is facing me. So this is like it was mounted on the handlebar. Just as you're facing it like this, you would be looking at the sensor in the same orientation on the bike. So I don't know what I did there. Oh, it's talking with my touchpad. So this is the orientation, and clearly the orange line that's being plotted at the top is the version of the tilt. And as you can see, it tops out at 90. So as I tilt the accelerometer this way, it live plots the tilt changing up and down. So you can see that. And then I've got a button, GP20 on the baseboard, which when you press it, it mimics like the speed is changing. So now the green line in the plot is going up. And unfortunately, the plot rescales itself all the time. But you can see the speed going up to 30 and up to 40 and up to 50. Like I said, every press increments it up to a maximum of 50, or a maximum of 90, and then it heads back down again. So if I can try and use two hands, I can actually tilt and change this. Tell you what I'm going to do. I'm going to leave the speed fixed. I'm going to leave the speed fixed at 30. And now let me bump it up to 50, just to get it in the middle of the plot. And the blue line, which is down here at 10 right now. Oh no, the state line is at 10, I think. Let me grab my accelerometer and get it oriented. Okay, so right now my speed is 50 and my tilt is 90. So this is a safe operating condition. I'm not exceeding the speed for which the current tilt is unsafe. However, if I were to change my tilt such that it decreased down to the level of the speed, it changes the state, and you can see the blue line at the bottom, hopefully, of the plot. It shows you the state. So right now, this is an unsafe operating condition. My speed exceeds a safe tilt angle. As I bring the tilt back up again, I'm back in a safe operating condition. So the blue line moves up and down from safe to unsafe. So it's actually plotting the state along with the two parameters of tilt and speed. So you can see it jump up when it's unsafe, and the bottom one goes back down when it's safe, unsafe, safe. And because all comparisons like this kind of need some hysteresis, you'll see in the code that there's a hysteresis band of like 10%. So as long as the speed is 90% of the tilt, it is safe, in a safe operating range. And if it's above like 110% of the safe operating range, then that's an error. Otherwise, if these two values were to get close to each other, you'd see a buttload of events get generated, and that's basically useless for a state machine implementation. So let me take off the plot. And actually, I'm going to turn off the plotting feature because I want to be able to show you the events. So I want to turn plot data to false. I want to hit stop. Okay, change that to false. And I got to warn you, because this program uses interrupts, almost every time you stop the program, you have to reset the processor by pressing the reset button on the baseboard. And then hitting stop to reconnect, and then hitting play again. So now this turns off essentially the live plotting, so that now you can just see the event messages. Oops. Move this out of the way, move that out of the way. Okay, so hopefully you can see at the bottom of the screen now. Oh, there's reflection. Okay, so down at the bottom of the screen, you can see that there's no state changes. But as I whip the accelerometer around, okay, so right now the speed starts off at 0. So I have to up the speed. I'm going to do 5 clicks to up it to 50 miles an hour. And it's safe because my orientation of my tilt is 90, so it's kind of in the safest tilt section. Now, as I tilt the accelerometer so that its tilt value gets to be close to the speed value, you can see you get a event goes from, it says event now dangerous is the name I've given to the event. You can change it to whatever you want. And as I right the bicycle, it comes out, it chatters a little bit across the threshold, I guess, because I was wiggling. I got multiple events, but so you tilt it and it crosses, it gives you one event, and you tilt it back to safe and it crosses again. You get events on both directions. So I hope this is a good starting point for you guys. You'll have to replace all the fake math. You'll have to do real speed computation. So you're going to want to, time the difference between pulses in the interrupt handler. And there's actually a little bit of sample code in there to get you started on where to do that and how to do that, but I don't do it for you. So you're going to change the interrupt handler to take my notion of fake speed and change it to a real notion of speed. So that's for you to do. And then you have to do the real math to figure out what the tilt is based on which axes you want to use, depending on how you're going to mount your accelerometer and how many axes you want to do. You can do tilt in one space, one dimension or 2 dimensions. You probably can't do tilt. I don't think 3 dimensions makes sense. But so anyhow, that is what you get here. I put a fair amount of comment documentation at the top of both the Eventoid and the demo program, so I'm hoping it'll be self-explanatory, but expect to spend a couple of days figuring out how everything actually works together. That's to be expected. You're not programming geniuses, so expect to be frustrated for a little while, but you're welcome to run the demo. You probably have everything you need. You probably have an accelerometer, and you certainly have a baseboard with a button on it. So you've got all the pieces you need hardware-wise to be able to reproduce the demo. And it should run right out of the box, just as I've shown you how it works here. And I can't think of anything else to tell you at this point. So definitely spend some time looking at it before you start asking me questions, because to be able to understand it and make changes to it, you're going to have to suffer looking through it and figuring out how it works for a while. Otherwise, you're just going to be flailing without really understanding what's going on. You're never going to get your project done, well. So if I got the model wrong of how your project is actually going to work, I don't think it really matters, because the structure of the eventoid is such that you should be able to twist it and tweak it and spin it and bang on it to get it to work. I think structurally it shows you all the types of things that you might want to do with it, and I think it's all there. You just might have to move some stuff around. So I hope that helps, and I think that's about it. So after a couple days, feel free to go ahead and send me some email if you have some questions, but my answer might be, well, I documented that. You should go and figure it out. So like I said, I'm not going to do your project for you. This is a learning experience for you and not for me, although I did learn a bunch by doing this. And I hope you do too. So that's it, and I will catch you guys later.